Hello, everyone. This is Cavell. Today, I will be talking about a problem that deals with distance equals rate times time. So, with problems like these, they're quite difficult to understand at first, only because it's hard to wrap your head around some of these principles and the way things work. But today I will be helping you with that, and I'll be solving this problem step by step, and you can see what's going on, maybe my thought process, and hopefully it'll help you understand. So let's start. So it says an airplane travels 720 miles in 3 hours with the wind. The return trip against the wind takes 4 hours. And then it asks, what is the wind speed and the speed of the airplane in still air? Right? So before we even start this problem, let's write down an equation that we need to keep in mind. So the equation is d distance is equal to rate multiplied by time, or in other words, distance equals to rate times time. Right? So far so good. So let's read. When it comes to word problems, it's always good to read it line by line and kind of parsing the information or the necessary information and see what you can do with it and translating that into equations. So the first line says an airplane travels 720 miles in 3 hours with the wind. So what's our distance? Our distance is 720 miles, right? And then it says it travels that distance, 720 miles, in 3 hours, right? So for the time, we could say 3 hours, right? And it's going with the wind. So if we think about an airplane, right, and we're thinking about how fast it goes, is it faster if it goes along the wind or against the wind? Obviously, it's going with the wind, right? Think of even streams. When you're going downstream, that's a lot quicker than going upstream, right? So what's our rate? So our rate is going to be composed of two variables, right? So we have a variable for airplane speed, right? So this is airplane's speed. And then we have wind, or W for wind speed, or wind speed, right? And now if we take a closer look at this, the rate in which this airplane is traveling would be the sum of the airplane speed and the wind speed. So we would just do A plus W. Okay, and this is all being multiplied by the 3 hours because remember, its distance is equal to rate times time. And remember, this is with the wind, right? So now for the second line, it says the return trip against the wind takes 4 hours. So the distance still stays the same, right? 720 miles, right? But what's our rate? Well, if we're going against the wind, it's going to be slower, right? The plane is not going to be moving as fast with the wind obstructing its speed. So in that case, the airplane speed would be subtracted by the wind speed. So that's our rate. So it'd be A minus W, right? And what's the time? It says the return trip against the wind takes 4 hours. So we'll write 4 hours. Okay. So now we have two. So let me label this. This is the first equation was with the wind. The second equation is against the wind. Now what we need to do is solve for these two variables, a and w, and it's good that we have two equations, because in order to solve systems of linear equations, we need as many equations as there are variables. So if there are two variables, we need two equations. So in general, we have two equations. 720 is equal to a plus w times 3. We have 720 is equal to a minus w multiplied by 4, right? So let me just erase everything here, just so we have a little bit of room. There we go. All right. So as you can see, we can actually, so let's solve for the first equation, simplify it. So as you can see, we have a 3 on the right side. We can simply divide both sides by 3, right? So this is what it would look like. Divide by 3. Divide by 3. 72 divided by 3, I believe, is 24, and we'll tack on a 0, so that'll be 240 is equal to a plus w, right? The second equation, we have 720 is equal to a minus w multiplied by 4. We could divide by 4, right? And then if we do 720 divided by 4, we get 180 is equal to a minus w, right? So let me just have these two equations here. So we can solve this using two different methods. We can either do elimination or substitution, and I will definitely do both because they're quite simple. So if we do substitution, right, we could either solve for a or w. I'll solve for a, so I should get from the first equation 240 minus w is equal to a, right? And then I plug in this relationship or this equation into the second equation, so I get 180 is equal to, so everywhere I see a, I write 240 minus w. So I'll have 240 minus w, this is for this part, a, and then minus w. Now I just get 180 is equal to 240 minus 2w, right? And then if I just move this so I can have a little bit more room. So if I minus 240 minus 240, I get minus 60, right? Is equal to minus 2w. Now to solve for w, I divide both sides by negative 2, so I get negative 60. So come over here. Negative 60 divided by negative 2 is equal to negative 2w divided by negative 2. I get 30 is equal to w. So if you remember, w is the wind's speed. So if we plug this back into this equation, where a is equal to 240 minus w, right? I get a is equal to 240 minus 30. A is equal to 210. So in other words, we have wind speed is equal to 30 miles per hour, and then airplane speed is 210 miles per hour. But now if you want to do substitution, or sorry, elimination, right? Let me just erase this. Let me just erase this, this. So we'll put this up top here. Okay. So if we do elimination, right, we can do this. So we'll start back up here again. For elimination, we can see that we can actually eliminate by adding these two equations, because W is opposite of this W here. We have a positive W and a negative W. So if we add these together, they would cancel out. So in other words, I would be adding these equations together, and I would get 2a, right, is equal to 420, right? Divide by 2, I get 210 is equal to a. And here we have the same answer. Airplane's speed is 210 miles per hour. And if we look back to this equation, or either of these equations, we have 240 is equal to a plus w, right? But we know a is 210. So we can say 240 is equal to 210 plus w. Or if you want to use this equation, we'll have 180 is equal to 210 minus w, right? And in each of these equations, we can see that w equals to 30. W equals to 30, right? Because 210 plus what gives me 240? That's 30. 210 minus what gives me 180? That's 30. So that's how we found what A and W are, or the airplane speed and the wind speed is. So it's also important in math to always check your work, right? It would be quite unfortunate if you did all this work just to have it be incorrect. So in that case, let's check. So we have an airplane going 720 miles, right? This is distance in 3 hours. So we'll write 3 hours. And then the rate would be the airplane plus the wind speed, right? If we're going with the wind. So we have 210 mph plus 30 mph, right? You have to remember that 210 is the airplane's speed, and 30 is the wind, right? So we have 3 hours, 240 miles per hour, right, is equal to 720 miles. Put a question mark, right, because we're checking. The hours cancel out, right? Then we're just left with 720 miles is equal to 3 multiplied by 240 miles, right? And then we can see that 3 times 240 is 720, so 720 miles is equal to 720 miles. So we put a check, right? So we checked it for the first set of conditions. An airplane travels 720 miles in 3 hours with the wind, and it actually worked. Now we need to check for the second one, the return trip, right? The return trip is still the same distance, right? But the rate is a little bit different because we're going against the wind. So if you remember, it was A minus W multiplied by 4 hours, right? So once again, we plug in A and W, right? So we get 720 is equal to, so I'm putting these questions marked because we're still checking the answers. So we'll have 210 mph minus 30 mph times 4 hours, right? this just becomes 180 miles per hour, right? 4 hours is equal to 720. Oh, so remember there should be miles in this. So here, here you go. Let me move this. Let me move this. Should be miles. Should be miles. Here you go. Let me just delete these. This should be equals, equals, equals. So as you can see, the hours on the right side of the equation cancel out. We get 720 miles, right? It's equal 180 times 4, right? Because the hours cancel out. And actually, almost forgot again. Miles, right? 4 times 180 is actually 720. And the unit of measurement is miles, right? So there we have it. They're actually both equal to each other. That means our answer is actually correct. So just to conclude, right? The speed of the airplane is 210 miles per hour. The wind speed is 30 miles per hour. And that's it. Thank you for watching. Bye bye.